Let's recap what we've seen so far. We've seen in this course several strategies or families of algorithms that let us solve problems in polynomial time without exhaustive search. The interesting thing is that you've already seen in this course most of the strategies that we know about. So for instance, divide and conquer works, roughly speaking, when a problem can be broken into parts that can be solved independently. Dynamic programming works when there's a small number of initial choices that then break the problem into parts and rule what your options are for your remaining choices, so that the total number of subproblems you'll ever need to deal with is only polynomially large. Greedy algorithms, also known as local search, work when the landscape of the problem is simple, so that no matter where you start, as long as you repeatedly make some improvement, you'll reach the top, you'll reach the global optimum. But if the landscape is bumpy, this just doesn't work. We touched on another family of algorithms with this duality between max flow and min cut. And it turns out that these are examples of a class of optimization problems called linear programming, which are also popular in economics, for instance. There's also a more general set of algorithms, optimizations that are often used in machine learning, called convex programming. We don't have time to really cover these in this course, but what I want you to know is that these families that we just named are essentially all we know about. So is that all there is? Are these the only strategies that let us cut through the exhaustive search and solve a problem in polynomial time? We haven't actually been thinking about algorithms for that long, historically, we, the community of computer scientists, in which of course you're included. And it could be that there are completely different strategies that no one has thought of yet, or it could be that there isn't much more than this. We honestly don't know. So what we're going to think about next is the question of fundamental limits on polynomial time algorithms. It's one thing to think about, does this strategy work? Does that strategy work? But when might we be able to show that no strategy works, that you have to do exhaustive search? How would we even prove that and make it stick?